I'm going to solve an example problem of using the disk method to find the volume of a solid revolution. Before I do that, there's a calculation we're going to need in the problem that I would just as soon do now off to the side. So in this problem, we're going to have to take this quantity, x squared minus 4x plus 5, and square it. So remember, to square a quantity, we just multiply it by itself. Okay, so we do sort of an extended FOIL on this. We're first going to take this x squared and multiply by all three terms. So x squared times x squared is x to the fourth. X squared times negative 4x is negative 4x cubed. And x squared times positive 5 is plus 5x squared. Then I'm going to multiply this negative 4x times everything. So negative 4x times x squared is negative 4x cubed. Negative 4x times negative 4x is positive 16x squared. Negative 4x times positive 5 is negative 20x. And then I'll multiply by the plus 5. Plus 5 times x squared is a plus 5x squared. Positive 5 times negative 4 is negative 20x. And positive 5 times positive 5 is positive 25. So when I put this all together, I get x to the fourth minus 8x to the third plus 26x squared minus 40x plus 25. So again, I'm going to need that in the middle of this problem, and I just don't want to take up the space on that problem itself. So make note of that. We're going to use that in a place in this actual problem. So let's go to the problem itself here. Find the volume of the solid created when the region bounded by y equals x squared minus 4x plus 5, x equals 1, x equals 4, and the x-axis is rotated about the x-axis. So I'm rotating about the x-axis, so I'm going to be rotating in that direction, right, around the x-axis there. X squared minus 4x plus 5 is a parabola. My vertex of the parabola, remember, is negative b over 2a. That's my x-coordinate. So b is negative 4, a is 1. And so I get a negative of a negative. That makes a positive. 4 over 2 is 2. So the x-coordinate is 2. The y-coordinate then will be 2 squared minus 4 times 2 plus 5. That will be 4 minus 8. Negative 4 plus 5 is 1. So my vertex is at the point 2, 1. All right, now what about some other points? If I let x equal 1, then y is 1 squared minus 4 times 1 plus 5. 1 minus 4, negative 3 plus 5 is 2, so we would have the point 1 comma 2 on the parabola. And if I plug in 4, we would get y is 4 squared minus 4 times 4 plus 5. So 16 minus 16 is 0, plus 5 is 5. So I get the point 4 comma 5. And that's a parabola, so it would be this sort of a graph, something like that. And I'm then going between x equals 1, x equals 4, and then the x-axis down here. So that's my two-dimensional region. If I'm rotating about the x-axis, I want my rectangles to be perpendicular to the x-axis. So a sample rectangle maybe would be here. And what I have to look at is what happens if I rotate that around the x-axis. The other thing, of course, I can sort of do is think about at least what this is going to look like a little. Like I could, imagine sort of flipping this over, and we'd have a shape like that. And of course, then it would be, something like this. So that's sort of what that solid is going to look like when I rotate it. I'm going to get rid of some of that because it's going to obscure what I want to do here. So let me get rid of what I've just put in. Okay. And what I'm going to do then is rotate that rectangle. That's going to give me a disc, right? When I rotate that, it's going to look something like this. And I'm going to have to sort of figure out then what this R is there. The top of the disk is on the function, which is y equals x squared minus 4x plus 5. The bottom of the rectangle is here on the x-axis, so that would be y equals 0. So my radius is the top y-coordinate, which is x squared minus 4x plus 5, minus the bottom y-coordinate, which is 0. So my radius is just x squared minus 4x plus 5. And so the volume of my disk, well, this is a little change in x here, right? I've got a delta x. That's the thickness of that rectangle. It's going to be pi r squared, that's the area, times the thickness, which is delta x. So that's going to be pi times this x squared minus 4x plus 5 quantity squared delta x. And that's that thing that we evaluated on the first page. So to find the overall volume, then we're going to integrate this. We'll pull the pi out. We're going to integrate this x squared minus 4x plus 5 squared dx instead of delta x. And then the limits are going to be x limits of integration. So what's x going between here? Well, we're starting at x equals 1 and we're ending up at x equals 4. So this is going to be pi times the integral from 1 to 4 of this result that we got on the other page. That was this x to the 4th minus 8x cubed plus 26x squared minus 40x plus 25 dx. So that's going to be pi times, I'm going to go down a little lower so I don't run into that box over there, just down a little. So pi times, now I have to take the antiderivative. So I increase the exponent by 1, that'll be x to the 5th, and then I divide by 5. So x to the 5th over 5. I'm going to get 8x to the 4th, and then divide by 4. I'm going to get 26x cubed, and then divide by 3. I'm going to get 40x squared, and divide by 2, and then 25x, and that's evaluated between 1 and 4. So I'm going to plug 4 in for x. Let me just get a better 25 there. So I'm going to plug 4 in for x, and then 1 in for x, and then subtract. So we're going to get 4 to the 5th over 5. Now the 8 over 4 is just 2, so 2 times 4 to the 4th plus 26 times 4 to the 3rd over 3. 40 over 2 is 20 times 4 squared plus 25 times 4. But then I'm going to have to plug in 1. So I'm going to get 1 to the 5th is just 1. 2 times 1 to the 4th, 1 to any power is 1, plus 26 third times 1 to the 3rd, but 1 to the 3rd is just 1. 40 over 2 is 20 times 1 squared is just 1, and then 25 times 1 is just 25. So what do we get here? Well, 4 to the 5th is 1024. 4 to the 4th is 256. So 2 times 256 is 512. You can do all this on a calculator if you need to. 26 times 4 to the 3rd, well, that would be 26 times 64, which is 1,664. And then we get 20 times 16, so that's minus 320. And then plus 25 times 4, plus 100. And now I distribute the negative, I get minus 1/5, plus 2, minus 26 thirds, plus 20, minus 25. All right, so we've got 1,024 fifths minus 1/5. So that's going to be 1,023 fifths. Let's see, I've got negative 512, negative 320, what was this? Plus 100, plus 2, plus 20, and minus 25. If I put all that together, that gives me negative 735. And if I look then at the cubes that are left, the thirds that are left, I get plus 1638 over 3. So that's pi. We get 1023 over 5 minus 735. It turns out 1638 over 3 is 546. So I get 1023 over 5 minus 189. So 1023 over 5 minus 945 over 5. Which gives me 78 over 5, and I can just throw the pi in the numerator, and that would be the volume of that solid.